Alright, let's talk about units and conversion factors. The units in a measurement are just as important as the numbers are, and in chemistry we make sure that we use a system that's dependent upon a reference standard. That means that it's a standard that is universal throughout the world. We use the metric system. It's also called the International System of Units, or the SI system. It's French. They switch the letters back and forth. You know, what can you do? Basically, the nice thing about the metric system is everything is either based on 10 or multiples of 10. So it makes manipulating it very, very simple. You've got 5 basic base units. So meter for length, mass is the kilogram, time is seconds. Thermodynamic temperature is the Kelvin. We'll get into that more when we get into the gas laws. And the amount of substance is the mole, and that one there will come back to haunt you for most of the year. Pardon me. These units can be used to derive other units like liters for volume, grams per milliliter, or grams per centimeter cube for density, degrees Celsius for temperature, and the joule for energy. Now, these units are pretty big. You can't measure the head of a pin with a meter stick or the mass of a fly with a kilogram. So we have prefixes to turn large units into smaller ones or into larger ones, something we can use to measure something bigger. If you really want to get big, you use mega. Mega means that it's 1,000,000 times bigger. Kilo is 1,000 times bigger. You know, 1,000 meters go into a kilometer. 1,000 grams go into a kilogram. Centi is used for 100 times smaller. Think 100 cents on the dollar. There's 100 pennies, 100 cents in $1. Milli is 1,000. So there's 1,000 millimeters in a meter. Micro, that funny little letter there is the Greek letter mu, means it's 1,000,000 times smaller. So if you have 1 meter, that's 100 centimeters. If you have 1 megameter, that's 1,000,000 meters, which is quite a bit. 1 kilogram is 1,000 grams, and so on. So we can use these prefixes to make our units, our base units, larger or smaller as we need them. But in order to do that, we have to convert from one unit to another. And a conversion factor is really straightforward. Basically, the top number and the bottom number are going to be equal. They're both going to equal the same quantity. For example, 4 quarters equals $1. And it really doesn't matter if I've got 4 quarters on top of the fraction or $1 on the top of the fraction. So 4 quarters over $1 or $1 over 4 quarters, they both equal 100 cents, $1 worth of money. And we use these conversion factors to convert between units. So for example, if I wanted to go from 750 centigrams into grams, I would either use the 100 cg over 1 gram conversion or 1 gram over 100 centigrams. In order to get from centigrams to grams, I need my centigrams to drop out of the equation and cancel out. So I'm going to put 1 gram on top and 100 centigrams on the bottom. So 750 centigrams times 1 gram divided by 100 grams. I'm not changing the value, I'm simply changing the size of the unit. Means that this is going to convert out to 7.5 grams. Same thing if I were to do this with 14.5 kilometers. I wanted to know how many meters there were. If I start with kilometers, kilometers has to go to the bottom of the conversion factor so that they can cancel each other out and drop out of the picture. So 14.5 kilometers times 1,000 meters and divided by 1 kilometer gives me 14,500 meters. It's pretty straightforward stuff. We're going to do a lot of it in class, so get ready.